Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to another amazing, wonderful, electronics stuffed Ask an Engineer. It's me, Lady Ada. I'm the engineer on call for tonight. With me is Mr. Lady Ada. At home, we have a cute cat named MOSFET, which we'll show a photo of later, but he's not allowed in the factory. But it's still a party here. We're broadcasting live. We're in this factory. We've got things. We have an on-air sign. We've got tons of electronics. And we've got a very exciting show for you tonight with all sorts of news and videos and, I don't know, contests, prizes. Tell them what's on tonight's show.
Good, I'm glad you asked. On tonight's show, the code is PyHackAda. That's 10% off all the way up until 11:59 p.m. Eastern Time. It's part of our Hackaday I.O. contest. We're giving away Pi Zeros, the elusive Pi Zeros. Show and tell. We'll talk about the people who show and shared projects live.
They were live. We're live. We're all live.
Pack of the mailbag will stop by.
No replicants here.
Yep. And we'll read some letters that you sent in. Help wanted, the Adafruit jobs board. Time travel, look back in the world of hackers, makers, artists, engineers, pioneers. If they did something interesting, they're on the time travel. Wearables, we got a great teardown of a cool wearable. 3D printing, great video and time lapse. Pi video, we have a world premiere of the Pip-Boy.
Pip-Boy 3000, yeah.
Yeah, because it's made with Raspberry Pi. New products, we're going to answer your question. We have a trivia question. We're going to have a top secret.
I do.
All that and more on
Good. I was
Ask an
like,
Engineer.
make sure I had brought my top secret because I got to top secret it up.
Yeah. Okay, let's pay some bills. So it's PyHackAda that gets you 10% off an Adafruit store, as I mentioned before. And the cool thing about that is it goes all the way up till 11:59. So you can save it now if you want, but you can do that.
And then you get 10% off everything in the store except for software and gift certificates.
And we are reader, viewer, listener supported, as they say in the
hacker supported.
In the hacker supported. So your orders is what fuels all of this. So please.
Yeah, we don't have VC funding or loans.
No,
we might one day, but we don't right now. We just do what the community wants.
Okay.
Thanks, community.
Yeah.
You're awesome.
And a couple odds and ends here. So we still have the $200 free tier. So $200 or more, you get free UPS ground if you're in the U.S. And we have the Perma Proto in Manhattan. Free same day. Sorry, not free. There is a tier for free.
There is a same day, but we do have same day delivery. Oh boy, it's been a day.
Yeah, my phone was ringing right before. And then we have a couple other things like if you order before 11, that's when it shows up.
Yep.
Because we need a little time to get it to you. So just
you can get it the same day. Just order before 11 a.m.
Couple caveats with it.
Has to be it's a certain district, but it will be available for you on checkout if your zip code is one of the available ones. You can also look at the delivery page for information. And basically we have a courier come here, we'll pick it up and deliver it to you. You will get it by, I think, like 5:30 p.m. that evening. So we have advertising agencies do it all the time, students do it all the time, artists do it all the time. You just really need it today, you want to work on it tonight, you can do it. Yeah.
And a programming note, this is Ask an Engineer, 8 p.m. every Wednesday. And Show and Tell is every Wednesday at 7:30 p.m. Eastern Time. We've been doing Deaths of Lady Ada quite a bit. Yay! And then
it's me. It's my desk.
Yeah, and during this month, we're doing at least 10 Deaths of Lady Ada, which is part of our PyHackAda or Pi Zero contest that we're doing with Hackaday.io. And also, I want to play a quick little video. This is the old soundtrack from Tony's new show, but here is the intro to Tony's show.
He's also doing a show.
He's doing a show from Deaths of Tony, so here it is. Okay. So that is the Desk of Tony show.
Yeah, so Tony's also doing streaming, and he did a stream last weekend, and y'all can check it out. He did a nice long stream about adding Adafruit I/O capabilities to his desktop Linux Raspberry Pi project. But he's going to be trying to do one maybe once a week, maybe on Fridays. Of course, no promises, but and so he'll be streaming. So you have 2 desks of engineers, and hopefully we're going to start a trend. I think this year is the year of live streaming video for engineers.
Yeah.
Yeah.
Yeah, if it's not live, anyone could do jump cuts and edit yourself to really do anything.
Yeah.
That's how they made Avatar. I don't know if you knew. Editing.
It's
Does everyone even remember Avatar?
Yeah,
Really?
it's one of the biggest videos. What's interesting about doing live engineering is it's like you really get to. It's a lot harder than one thinks. You actually have to have everything work out perfectly if you want it to work out perfectly, or you have to just know what's going wrong when something's going wrong. So you don't have the few minutes to realize, like, oh, you plugged in the wrong USB cable, or like, you know, your battery got drained or whatever. So it's kind of fun to watch. Definitely have. I had a stream a couple days ago where I actually showed a mistake that I made while routing a PCB. You'll have to watch the video. It's called Lessons Learned to find out what I did wrong with the circuit board design. It's a common hang-up that engineers get caught by. But it's kind of fun because whatever I'm working on that day, I get to show it off, and whatever Tony's working on. So, we also do recorded videos, but I think the stream videos are fun.
Okay. All right. Next up. So show and tell. We do this every single week.
Yep.
7:30 p.m. Eastern time every single week. This week on the show and tell, who's there, Lady Ada?
I will do the show and tell. So start off, I'm not going to go, yeah. Tony D was first. And so Tony Nicolo just said he's doing this live streaming, so that's one of the things he's working on. But he's also doing an overhaul of our Python libraries for the Raspberry Pi. So 4 years ago, I did with K-Town, I think, because Tony D wasn't with Adafruit yet, we wrote a whole bunch of Python code to use our sensors with the Raspberry Pi. And the code does work, but I'm not known for my cleanliness of code, and so I mixed tabs and spaces, and it's Python 2, and I didn't make it work with Python 3 because I'm a Python 2 adherent. And also, everything is in one repository rather than on the PyPy repository, the online package management system. And so he's actually going through and doing that. He's going to pepate everything, put everything on PyPy, and also clean everything up into multiple different repositories and make sure they all work on Jessie. It's not exciting, glamorous, but it's much necessary. So I want to give him an extra shout out for the work he's doing. Noah and Pedro are working on a Pi Pip-Boy. It's awesome. You're going to see it. We're going to show a video soon. It's 3D printed, has a Raspberry Pi and a Pi TFT, and has a rotary knob, so you actually get to like turn and twist it. It has a little speaker, can play audio as well. Phil B is worked on and finished a project this week called Lightship, and it allows you to make, in the most basic description, elevator pitch possible, it's basically a Wi-Fi fade candy. Instead of having a USB connection to drive pixels from your computer, it uses that same protocol, but it's over Wi-Fi. And it uses our new Feather M0 to stream pixel data and then do dithering and interpolation with little portable shapes. So we thought this was really good for wearables or performances where you want to stream LED pixel data without a cable, because maybe you want to have something without a cable, battery powered. We have Roberto, who's working on custom OpenSCAD export tools to help him avoid changing a subsection that would change all of his 3D printed parts. Aiden showed off a parametric bending actuator that he's using with Thingiverse. Thingiverse has parametric tools. He's got that going on. Richard showed off this awesome rainbow unicorn suit that has a gigantic zipper. I mean, he's just really down with these gigantic zippers, and there's like a horn and there's like a skirt, and it's a cool looking outfit. So I don't know what it's for. Maybe it's a wedding dress or something. I don't know. Philip Coffey came by to show off his DIY monitor, steampunky monitor, built into a cigar box with the Raspberry Pi, and also he's building a 15 by 28 foot workshop, and it's in progress. So you can see it's in progress. Grace Spy also came by and showed off an OLED video game. It's kind of like an asteroids game, and it's running on a photon. So the code is all written on the Photon online particle editor and then downloads automatically. So it's a pretty intense project, but there's like buttons and video game action. And then finally, last but not least, Monica from Hackster.io came by to tell everyone that Hackster Live is doing a meetups program, and we're sponsoring them, helping them get the word out. Sign up to be an ambassador by going to hackster.io/live, or just go to the Hackster.io site and sign up for their new ambassador program. If you want to run meetups, run workshops, you'll get discounts for Adafruit stuff. It's a good time.
Okay. All participants in the show and tell get it as seen on the show and tell sticker. All they have to do is email support@adafruit.com, and we send them out a physical sticker.
The stickers are cool.
Yeah. And
you get multiple stickers too.
The Hackster.io stuff /live is something we're doing new. We're a sponsor, and they're able to get our hardware at reseller prices, so they'll be able to deliver it to the people who have the events. That might be one of the new things we start talking about when we say show your projects, your retro tech. It might be show your event. So,
I'd love that. We've had hacker meetups that show up and like, hey everybody, and I'm like, hey everybody. That would be so cool. And we also do special messages. So if you do want me to say hello to a group of people, we do that. We'll do that on the show and tell. We can broadcast, and I'll say hi, and they can show off their projects, and we can do feedback. We've done that. We did it with Oracle, and it worked out really well.
To get on the show and tell, all you have to do is go to google.com/+Adafruit and look for the show and tell post that's there every single week on Wednesday at 7:30. Go to the show and tell post, and there's a link. We have so many people in the show and tell circle. Just look for the link and click that, and you can get in.
Yep.
It usually fills up, so if it does, just know we do it every week. And
every week from now till the end of time.
Yeah. Okay. Mailbag, packet.
Packet the mailbag.
Yeah, we read these letters to the entire company at our weekly State of the Fruit. We also read them here on Ask an Engineer.
Do you want me to read
This is from Ellen. Yeah, read it.
Okay. You are unbelievable, Jessica. Jessica is the lead of customer support. Please forward this email to your supervisor. That's me. With high compliments to you, especially in your customer support team philosophy for outstanding customer service. An immediate response at 5:04 p.m. on a Friday afternoon is absolutely amazing. Sincerely, Ellen. Thanks, Ellen. We work really hard to staff the customer support team and the tech support team to get you super fast responses all the time. We have weekend staff. We have evening staff. We try to get people the responses as soon as possible. We found that the faster you respond, the quicker we can solve the problem, just because we can just take care of it immediately. You know, it's like if we have to change your order or like update something or cancel something or get you an RMA, just getting it done fast. That's what we love to do. And Jessica's awesome. You're right. Nice work, Jessica. And Kelly and Rebecca.
Yeah. Jesse May.
And Jesse May. Sorry, Jesse May just joined.
Yeah.
Forgot Jesse May.
All right. Up wanted. This is adafruit.com/jobs. And that's where makers can post their skills and companies can post that they're looking for makers.
Okay.
And it's the best only jobs board like it online. It's free. This one's kind of interesting. They're casting for a real life MacGyver for a TV show.
Okay.
And I don't know if it's the MacGyver show, but they keep saying the word MacGyver. It's a TV network. Magilla Entertainment and a major cable network are now casting a real life MacGyver. Do you build your own furniture? Take apart random electronics and use the pieces? Solve complex problems with only your wit and basic objects? If so, we're looking for outgoing and fun personalities who have the knack to build, create, and design epic inventions and cool contraptions. So who knows? I don't know what this is. But
it doesn't seem to say that you can't be Lady MacGyver, and that was the thing that we were working on was, like maybe have Lady MacGyver. So all are welcome. Sign up. No promises you'll be a movie star.
Yeah. Okay.
Bright lights.
Open source hardware. That's us.
What's the news?
Well, I have some news.
Okay.
I'm going to say this. So, in the world of copying and counterfeiting, and companies looking at each other and saying, "Look at what they're doing. I want to do that." And ooh, it'd be cool if I could scrape a site and figure out sales data so I can figure out what to sell. All this copying, all this cloning. You know, it'd be really nice for people to copy.
What?
Celebrating things that need to be celebrated, putting people in the spotlight that aren't in the spotlight.
I thought this was going to go into an FTDI rant, so I'm really glad I didn't. Thank you.
On a side note, we're in contact with FTDI, and we're going to try to interview their CEO. We'll see how that works out.
But what you were really talking about...
What I was really talking about is everyone likes to talk about copying others that are doing well, or like, oh, that's a cool design, I'm going to copy it. Open source hardware encourages it. But I'm going to talk about copying something in a different way.
Okay.
So we're an open source hardware company.
That's true.
We have a blog, a website, popular videos.
We have 500 GitHub repositories.
We have 500 GitHub repos and everything. And so every single year we do something that other electronic sites not only won't do, but basically refuse to do. And that is celebrate the diversity in the maker world. So it's African American History Month. We have the blog devoted
It's
to...
the shortest month, guys. Like, it's
Yeah.
not even a big deal. Like,
So-
it's 29
so
days.
we-
You can do this.
So we have, I think it's 12 million views on our blog, and we decide to devote just one post a day. That's it, just one post a day.
One post a day.
Ain't a big deal, one post a day, and it's just celebrating someone in the African American history technology world that hasn't been celebrated, and we email other sites, and they basically ignore it. So this is the challenge.
Please steal.
If you were looking to copy us, sure, the designs are okay.
They're open
and-
source, they're
yeah,
licensed.
and you know, the idea of video shows and the way we do tutorials and all that stuff is interesting for market share and yay, business, let's compete. Please do this, because there are so many people out there that just don't get in the spotlight, and as soon as you get a platform, I feel like that's one of the things. And so thank you, Lady Ada, for having a blog from the start and all the stuff. We have a really big audience, and this
Yeah,
week...
if you're going to cargo cult, what's funny is that the cargo cult is like people copy the thing and they don't realize that it's the result, not the reason. You know what I mean? It's like the idea is like the cargo cult come from like, oh, if you paint an airstrip doesn't mean planes will land. Like you have to build an airstrip before and then planes will land. But like it's not like the landing strip itself is what causes them to
Yeah.
land. So people are like, they're copying our designs and our ideas and our marketing, but they don't understand that it's the cause and the feelings and the reason and the things that we want to see in the world that makes Adafruit works out.
Yeah. So
Like the design, the electronics just come out of it.
So all that being said, please copy us. Please do this. If you're one of the websites that we've emailed and like, hey, this goes on every year, and there's even people in the maker community that aren't getting put in the spotlight. Please do this. So every day we have.
And you have 27 more days.
We have posts per day, and this is one from today. So this is Annie Easley, prominent 20th century computer and rocket scientist. Her career was both at NASA, where she simultaneously continued her education. Most notably, she contributed to research that was crucial in modernizing space flight. She studied in New Orleans, then she went to Alabama, then she helped fellow African American history study for the literacy test, where they were required to pass in order to vote due to the imposition of strict Jim Crow laws. Engadget last year was one of the few sites, and we posted about that also posted about her. Back in 2001, she was interviewed, and you can read the whole thing on NASA.
That's cool.
Yeah, and you know what? Most Americans and most people do not know about her. And so if you're in the engineering and electronics world, a simple blog post a day, once a month.
And you can just steal our blog post.
Steal this blog post.
Steal this blog post.
Yeah, anyways, so in addition to open source hardware having copying built into it, I hope that companies that do that also like the idea of copying information and things that need to get in the spotlight. So that's that. Speaking of putting things in the spotlight, 931 tutorials, Lady Ada.
Yeah, we did a lot this week.
Yeah.
Thanks.
Okay. What's on the tutorial?
We have a tutorial for our new DS 3231 precision real-time clock breakout. This is a little breakout board that puts the Maxim RTC chip on there. It's very small. There's a battery on the back. It's compact. It's very cute. Check it out. This tutorial basically just has the library and wiring and information, some links to data sheets. It's actually not a very complicated breakout, so not a very complicated tutorial.
Okay, next up.
This is the Mayo armband teardown. We'll show the video very shortly, but this is an epic teardown, and one of our most complicated, in-depth teardowns. A lot going on in this very interesting wearable that allows you to detect motion and muscle movement of an arm. You put on as a bracelet, and then you can detect how you're moving your arm around. It's kind of neat. I know everyone says like it's a Minority Report-y, but it really is very Minority Report-esque.
Okay, next up.
This is the Times Square word clock. So this is a little faceplate that you can 3D print or laser cut that will turn your Times Square watch kit, the little kit that we sell in the store, into a word clock. I might actually add this to the official firmware. That's kind of cool. Have this as a little add-on for the Times Square watch. But basically, then it lights up words. And it's a little 8x8 grid, so it kind of works out quite well, actually.
Okay.
And this is by Andy Doro and Daniel Wall, who work here in the fabrication department. This is that awesome tutorial that Phil B did I talked about earlier. So this allows you to essentially build a Wi-Fi fade candy. It's not exactly the same as a fade candy. It uses a dot star LEDs, but it allows you to stream LED video to a Wi-Fi embedded processor that you can basically put on the back of something or in a wearable or clothing. And so it allows you to, instead of having to write the code for the LEDs on your processor, you just connect it to a computer on Wi-Fi and you just stream the pixel data directly. So you can do much more complicated effects. This tutorial also, the code for it runs on the Cortex M0, and so it has a little bit of processing power to spare, so it can do the DMA for the pixels, which lets you have interpolation between frames and dithering, so it looks really, really good.
Yep. Next up.
This is an awesome Halo energy sword tutorial from Noah and Pedro, a fully 3D printed translucent energy sword with NeoPixel LEDs, and you can use Bluetooth to change the LED display and animations and stuff, and it's just awesome. And I thought it was tweeted by Xbox, so that's kind of cool. They were like, this is cool. So if you want to cosplay a Halo character, you can actually have animated LED 3D printed swords.
Okay, next up.
This is a tutorial by Lolly, who has shown up on the show and tell and emailed us and said, hey, can I put this tutorial up on the learning guide? And I was like, yeah, I would love to see a learning guide. It's a sound reactive LED pendant. It has a little NeoPixel ring. I think it has a Gemma inside and a little battery charger and a microphone. And so it just has it's a little piece pendant that you wear, and it has audio reactive LEDs. So it's kind of fun.
Next up.
I had a lot of tutorials this week.
Yeah.
This is a tutorial by Jeremy Blythe. He had a really great blog post about Pygame UI basics for the Raspberry Pi, and it's such a common question people have on how to add simple UI to a Raspberry Pi. And I was like, hey, can you write this up for the learning system? So we sponsored him to rewrite the tutorial and add a little bit and make it on the learning system so people can follow along, copy and paste code. We also updated the tutorial since in Jessie there's a little thing you got to do to make it work. Just follow the tutorial and downgrade SDL. I don't know. Open source software.
All right, next up.
Next up, this is a tutorial by Mike Barella. This is a fun little tutorial. Basically, the Raspberry Pi has, it's a full Linux computer and it's quite powerful and has audio, so you can make very simple synthesized speech projects. So, for example, you can make an audio book. You load in a text file on a USB key, press a button, and it will read out the book. Or the project that's the demo for the video is a talking clock. So you press the button and it will speak the time. So a lot of kind of interesting projects that you can do using speech synthesis and sensors and having new user interfaces, not just LEDs and displays, but talking to you. And I think you could probably even, with a microphone, do some basic speech recognition as well. So that could be kind of fun.
Okay. And that is it. So we're on our way to 1,000.
We're really close. We're like, what,
which
60?
Is way better than 302. And 931 is more than 302.
Wait,
and we are very
about
close.
3 times
We're
as
very
much.
close to 1,000.
Yeah, 1,000 is 3 times.
Yeah.
Also. But we'll get there. A couple more months. It's amazing that we have 1,000 tutorials, and all of them are like unique and individual. Like we actually have like 1,000 different tutorials, and each one covers something neat and interesting and teaches you something about electronics. So we will have to have a little bit of a celebration. Last week we had 1 million orders, 1 million thank yous, and soon we'll have 1,000.
Yeah, I was just talking to someone in the chat about like how do you support in a good way like 1 million customers, and so
it's hard.
and so
good documentation.
Yeah, and so here's what we found And this doesn't mean it would work for everyone, and this doesn't mean it's the best. If someone else comes along and does something better,
I'll learn from them.
we'll copy that. So what seems to work out the most is have a huge amount of information online in the form of structured learning like the Adafruit learning system. Have videos when you can. Have consistent foundation videos for all the other surrounding skills, and then have real live engineers that are answering publicly searchable questions either via the forums or Google for what they're looking for. So at all times, all the information is there. People often have call centers, that information's never shared. They have email support,
you don't know that
that's
the
never
person,
shared.
The thing is, another thing about the call center, the reason that it would never work for the stuff that we do, it wouldn't work very well, is the person on the phone may not have expertise in the thing that you're asking about. Like everybody who does technical work at Adafruit has their own skills. Like, I design the hardware, so I know like a lot of the reasons why certain things were designed. K-Town really knows Bluetooth Low Energy and Wi-Fi. Tony Nicolo really knows Python and like some of the B&O 055 sensors and some other sensors that he's really looked into. We have people who are really, really good at Windows code, people really, really good at Mac or Linux. And so depending on what your project or question is, you might need multiple people to come in and help. So we've had people who come in and they're like, oh, it's not working, and it turns out it's like a Windows driver, and then we solve that, and then it turns out that once they solve that, it turns out to be a power issue. And so when you have a forum, we have multiple engineers that come in and each has their own expertise, and so we'll have one engineer answer one part of it, and then they'll be like, okay, you've got to another issue, I'm going to pass this on to somebody else. But we have like a team of people that work together.
The thing that I never quite understood is, with electronics specifically, why would you not have the information publicly available? Because you're never going to come across.
Also, phone is the worst.
If you're a support person, you're never going to come across every scenario ever.
Yeah.
So when I hear that companies offer phone support for getting started with Arduino or something, that's insane. The best thing to do is to have great tutorials, videos, and then live engineers and real people that can answer each question.
Also, like we're constantly asking for screenshots, or people all have
they
phones.
Post videos, they do
photos.
multimedia.
So we'll have people take a photo, and actually a photo or video often helps. Like sometimes I'm like, I don't know what's going on, and I see a screenshot or a photo, and I'm like, oh, I see what's going on there. Like it's a wiring thing, or you have it in backwards, but you would not know over the phone. And with electronics, it's very visual. You have to see what the person's doing. Yeah. So that's why, like in the forums, if I jump in, I'm always like, hey, can you post a photo or a screenshot? Because like instantly, I can see what's going on.
What's neat with watching the maker movement over the last 10 years is if anyone figured out a better way to support 1 million customers, we would do it.
Oh yeah,
so
totally.
like it's not like we withhold ideas or like, ooh, like a hologram phone, that'll be cool. If anyone has any better ways to support 1 million customers, managing code with GitHub, that changed everything too. Like
GitHub's really helped.
Yeah.
But another thing is, we don't just replace it. Like, a lot of people contact us and they said that this thing I have is broken, and sometimes it gets damaged in shipment or whatever.
We actually find out pretty fast if there's issues.
But and that's another thing, by the way. If you have multiple engineers, it's all public. If there's one product that comes up a couple times, we can look and see if there's a manufacturing issue or a stock issue. But oftentimes we can help get the person's project fixed and running before we would have been able to send them another one. Because like just sending something multiple times and it turns out like it's not the hardware, it's the software or it's wiring, it's just not going to help them. So we actually try to get people's project working and solved, not just like, oh, let's send you another one, because otherwise it's like, okay, well I have 3 and it still doesn't work. And it's like, oh shoot, turns out like the GitHub repository, has a bug in it or has some debug code that wasn't commented out. Which happens. So.
Anyways, so it's interesting.
That's how you do it. It's not easy.
Yeah, it's interesting because no one has figured out how do you get someone to learn electronics from thousands of miles away. There's lots of strategies. We think we have the best one, but we're always interested in how people do it.
Yep.
One of the things I don't like is when you send an email and it does the auto reply from Zendesk thing, and you're like, oh no, it's like, please reply from the top of this email, and it's like, can you defrag your hard drive? Like, no, the serial output's not working. So anyways, that happened. Okay, so let's keep moving on. That was a maker business section, I'd say, tonight.
Okay.
Time travel. All right, so this week in time travel, makers, hackers, artists, engineers, scientists, pioneers. Here's a lady I didn't hear about. Do you know who this is? Mary Del Chilton, American chemist and inventor, one of the founders of modern plant biotechnology is born. One of the founders of modern plant biotechnology, taught and performed research at Washington University, St. Louis, and while she was there on the faculty in the 1970s, 80s, she led a collaborative research study that produced the first transgenic plants. Author of 100 scientific publications, and she's a fellow at Syngenta Biotechnology, and that's it. So
That's cool.
Yeah. So this is one of the.
She's got a plant.
Yeah. This is one of the people that did a bunch that we never hear about, like the first transgenic plant. Do you even know what that is? See, I don't know. It's a big deal.
Like, I guess plants where they it would be called GMOs now, right? Genetically modified plants where they splice genes from one plant to another.
So what happens is on Time Travel Tuesday, because I don't write it anymore, I look at it and I look up all these people and I'm like, oh my gosh, they're in everything.
Yeah.
But you don't hear about them.
I've never heard of this person.
Anyways.
All right, Mary Dell.
Mary Dell. It's not going to be the trivia question.
Thanks for plants.
Okay, Wearables this week. Wearable Electronics with Becky Stern. That was today. Colin co-hosted. It's every Wednesday at 2 p.m. Eastern Time. And today we have a teardown video of this very cool little device.
Yeah, I did this teardown a while ago, the Mayo.
Yeah.
This one was interesting. Check it out.
All right.
Welcome to another Adafruit Wearables Teardown. Today we're looking inside the Mayo armband. It's a gesture sensing device that you wear on your forearm. It has muscle sensors that detect the electrical signals when you contract your muscles, as well as an orientation sensor. So you can do whole arm gestures and also navigate through PowerPoint presentations, your music library, and other cool applications just by moving your arms with gestures. It communicates with your computer over Bluetooth, and after some simple calibration, you're all set to go. This device was really interesting to take apart because it has electronics in each of the cells connected by a flexible rubber gasket. Let's see what Lady Ada has to say about the design of the electronics inside.
Thanks, Becky. This is kind of one of the more interesting mechanical designs for wearables we've seen. Instead of like one circuit board and a wearable clip-on device, it's got multiple circuit boards and batteries and one main board and these sensors and what's going on here. So thanks for taking it apart. Let's look at it under the microscope. So first up there's the main board, and this is the board that kind of controls all the sensors that are in these little nuggets. So the main board, you've got your micro USB connector. What I kind of like is it's kind of a flat in line with the PCB design. It's got these big mechanical connections, and there's a cutout, and it sits in the center of the circuit board. So that's kind of cool. And then over here we have the main processor. So this is an MK22 FN M0 V12. This is a Freescale Kinetis Cortex M4 processor, kind of similar to what's in the Teensy 3.2. The M4 is the big sister to the M3, so it has DSP capabilities, which is probably why they picked this chip. They're going to do a lot of sensor analysis, taking like 6 different sensors and figuring out what are patterns between them, probably using some DSP in there. Over here, we've probably got some regulators, maybe a battery charger over here. We have a few LEDs, and there's these really lovely injection molded light pipes that are used to, the LED light, it goes over here, this sits in place, and it turns the light into like a lovely bar shape like this one, or a large flat shape. This is the other light pipe is over here. So there's, indicator lights, and that's how they get it out to the molded body. You've got a crystal over here for this processor. It's a BGA processor. Under here, this was actually had a little metal cap, and we pulled that off with hot air. And underneath here is our favorite, the NRF51822. This is the Bluetooth Low Energy Transceiver Processor, Cortex M0 processor, all in one from Nordic Semi. And you see this really nice ground stitching over here with the balun and then a ceramic antenna coming right off of here. They put it right next to the vibration motor, which is it's pretty ballsy actually, because this is extremely noisy. Maybe that's why they had to tin it. They put this tin on top to give a nice ground protection, so that the noise that's going to come from this motor, which is right next to the radio processor, I'm surprised that it works so well, but maybe they make sure never to use the Bluetooth at the same time as they're buzzing. Maybe they kind of alternate so that they don't have to worry about this noise feeding into here. It can flip over, and on the flip side, they've got a bunch of test points, programming. They're not labeled, but they're definitely going to be the programming pads for the Nordic. It uses SWD, as well as for the Kinetis processor, probably also either JTAG or SWD. And then over here, there's an InvenSense MPU 9150. This is kind of a well-known 9DOF sensor. I believe that this particular one also has built-in fusion, like kinematic fusion. So it uses the magnetometer, accelerometer, and gyroscope to tell you the orientation and movement. So it gives you quaternions and vectors rather than just saying, this is what the gyroscope says in raw data, this is what the magnetometer says in raw data. So you have to sign a couple NDAs and probably pay a licensing fee to InvenSense to get access to that. But for a high-end wearable like this, that's not a big deal. So this is what gives it the where in space is your arm, not just your muscle movements. So you have to have both to do proper gesture sensing. And then you've got a flex connector over here. It's got the little flip up so you can slide in this flex connector. 3 electrodes, and what it's doing is it measures the microvoltage differentials between the electrodes. And on the back, a little circuit. It's not exactly clear what it is, but I'll tell you what, whenever you see something that's sensing and you have a 14-pin chip, it's going to be a quad op amp, and the 4 at the end of the part number kind of gives it away, especially you see all these 0402 resistors and capacitors. This is the amplifier and signal cleaner upper for the electrodes over here. So probably amplifying it, doing maybe a little bit of filtering just to give you a band pass of what signals you're looking for, and then buffering it along to be read by the Kinetis with the DSP. So each of these are connected one after the other. And this one also has the battery, which is kind of interesting. They, instead of having the one large battery, they actually kind of split the batteries up so they could get 2 of these 260 milliamp hour LiPolys, but not have one big 500 milliamp hour one. So it's a little bit more expensive, and also you have to worry about charging and balancing them separately. This one does have a 3-pin connector, which makes me think that inside there is a temperature sensor or some sort of balancing control. Kind of an intense manufacturing process here, but it seems to me like they really, really wanted to have something very slim, something very elegant looking, and so splitting up the sensors this way, having a complicated flex circuit, multiple batteries, pretty hardcore processor, Bluetooth Low Energy, a lot of analog circuitry. So an advanced wearable, probably the most complicated one, and definitely the most I'm surprised it works category. So congratulations on making something that works.
For this and many other teardowns, we use these tools and the Adafruit USB microscope with its articulated stand. What wearable device should we tear down next? Let us know in the comments, and check out our other teardowns at the playlist in the link in the description. Thanks so much for watching, and don't forget to subscribe to the Adafruit channel on YouTube.
Okay, 3D printing, moving right along. We have a 3D printing video, but we also have a Pi video, so I'm going to do the time-lapse Tuesday video, which is 3D, and then I'm going to play the other video in the Pi section because it's related to Raspberry Pi stuff.
Okay, let's do the time lapse first.
Yeah, it's only 36 seconds.
Okay, time lapse.
Zip, 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 zip. Tomorrow is 3D Hangouts, 3 p.m. every Thursday.
Pedro.
Yeah.
They're awesome.
Yep.
The best, longest running
3D printing show ever.
3D printing show.
Yeah. Okay.
Pi
Yeah.
Pi
so
Day.
Pi Day. First, we're going to show a video. This I think is going to be big. It's going to make the rounds.
Yep.
It's because everyone likes Fallout. So
Fallout 4.
So
You're playing
here
it.
is a 3D printed Raspberry Pi Pip-Boy.
That's cool.
Yeah, that's good. That's a good part.
In this project, we're making a functional 3D printed Pip-Boy 3000 using a Raspberry Pi and Adafruit Pi TFT. The components used to build this project are linked below, and they're listed in the full step-by-step tutorial. The enclosure parts were 3D printed and designed to house the Raspberry Pi in the Pi TFT display. You can download the STLs and print them out yourself, or have a service like 3D Hubs print them for you. We designed the parts in Autodesk Fusion 360, and they're available to modify and customize. The Pip-Boy Python program for the Raspberry Pi uses OSM for map data, which allows you to browse your terrain rendered in glorious retro green graphics. It features an audio amp and a speaker so you can play the actual score or background music from Fallout 4. An analog rotary switch lets you switch between different modes, and you can toggle between different menu items. The 3D printed enclosure has cutouts for the Raspberry Pi I/O ports, so you can add peripherals like a Wi-Fi dongle, a keyboard, and even a mouse. The 2200 mAh battery can be recharged over USB, and it fits inside a pretty cool looking cylindrical case. The two halves are held together with really strong rare earth magnets, which makes it pretty easy to put it on and take it off so you can wear it with your favorite Dweller jumpsuit. So be sure to check out the learning guide if you're interested in building your own. The link is in the description. Details like the super bright yellow LED, the rotary encoder, speaker grill, and flux gauges really make this look like a Pip-Boy 3000 Mark IV. Thanks so much for watching, and be sure to subscribe for more 3D printing projects from Adafruit.
All right, and that was a special sneak peek of the Apple keynote coming in March.
You said there's the Microsoft Watch.
I didn't say that. I said that's the Apple Watch 2.
Okay. It's very steampunk.
Noah Pedro said it's the new Windows Watch.
Yeah, new Windows Watch.
And I actually have a whole collection of Microsoft Spot watches.
Yeah. All right.
Nice. All right, so next up, in Pi news, yeah, we're doing this Pi Zero thing.
Free Pi.
Yeah, so a million years ago, I started a site called Hackaday, and I had later given it to a group of people, and they've carried it on well. There's been different people, and the current people are pretty good.
Yay, Sophie.
Yeah, so Sophie and Adam are running this contest. Basically, you just come up with ideas. You're doing 10 broadcasts this month, and it's all about ideas that you can build with a Pi.
Yeah, so what you can do is we're going to give away 10 Pi Zeros, and the giveaway actually happens in the middle of the contest. So to get started, you sign up for hackaday.io. It's a free place to post up your project ideas and post up a cool project basically that would use a Raspberry Pi Zero. You don't have to have one. You can prototype without one. You can test stuff on a Raspberry Pi B plus or B or A or whatever. Or if you just have an idea that you think you can do. I mean, we're looking for creativity and fun and interesting and something maybe outside of the box. And halfway through on the 20th, on the 24th, the 25th, we will, the judges will review all the entries and pick the 10 most interesting, most fun ones, and we will send those 10 people a Raspberry Pi Zero for free so that you can continue working on your project, and maybe with this extra hardware bump, you will make it to the finish line. And then on March 14th is when the deadline for the final contest ends. And the top 3 entries will win $100 gift certificates to the Hackaday store. So you can actually win twice. You win a Pi Zero, and then you can win the final prize. And you can still enter this project into the Hackaday prize for 2016. So you can triple it up.
Yeah, and this is our help and hope to get more Pi Zeros out there. There's a limited supply. So instead of
this is my personal stash.
Yeah. So instead of overcharging and saying, okay, now they're $40, people on eBay are being really mean about that. They're charging a huge amount of money to try to get people to buy something that's in short supply. So we decided, well, let's give away them for free, and let's do that in a really positive way, coming up with ideas. So already, it's only been a day. There's already 27 entries.
And they're good entries.
They're all good entries,
nice.
And
Sensors,
they're all projects that people are going to make.
displays, little hats for it. There's some sort of autonomous car.
Yeah.
Your Raspberry Pi Zero $5 Linux computer
Yeah.
can do quite a lot.
So it's pretty cool. And
It's pretty cool.
Good work, Good work, Sophia. Okay, next up. Pi Hack Day. That's the code. That's what we were talking about. That's the contest. That's what everything is revolving around tonight.
Yeah.
You can do this.
And tune in. We're going to be doing. We're going to be doing 9 more broadcasts.
Yeah.
Come by and ask questions. We're going to do them live. If you have ideas or questions, you want me to cover something, or you want some suggestions for your project, I'm totally happy to do it. I don't know what days I'm going to be broadcasting. It's when I have enough energy.
Yeah.
But it tends to be in the evenings on the weekends.
It's on hacker schedule.
Hacker schedule,
Okay.
Tuesdays and Thursdays and on the weekends.
All right, new product time, Lady Ada.
Okay.
All right, new
Ready to do this thing.
Yeah, new products this week. First up, glitchy blanket.
Yeah. This
Can I
is,
take that home?
yes, this is
good.
for us.
All right, good.
So we get to keep one.
This is from Philip Stern, right?
This is a Philip Stearns.
Yeah, Phillips. Tonight is a night of Phillips.
All fills. So this is a really awesome glitch textile. I can hold this up. It's super soft and comfy, and it has this beautiful glitch
computer art.
effect on it. And I can show it on the overhead too later if you'd like. But it's like glitch art, but it's woven into this cool throw, and then you can cover your head with it, and your fears will disappear. Or you can wear it like a poncho a little bit. So there you go.
Okay.
It's kind of cool. I really like it, and it's large enough that you can put on a couch or a bed or whatever. But it is really neat. And we met Philip Stearns, and this is like really awesome art.
He's one of
and
my
the back
favorite-
looks really neat too.
He's one of my favorite living artists.
Yeah. Good glitch art.
Because it'd be, you know what? It's weird to say my favorite dead artist.
And aren't these made in Germany?
I believe so.
Yeah, I think these are made in Germany. So they're woven at a factory. He sends them the files, and they weave them. So this is kind of neat. Oh wait, here there's a little card that comes with it. Yeah. So if you want to check it out, philipstearns.com as well. Glitch Textiles.
Okay. All right. So next up, LED.
It's not an LED.
It's not an LED.
It looks like an LED,
not an
but
LED.
it's not.
So what is it?
This is a photo transistor. This is a sensor, and there's a little. It's kind of the opposite of an LED. When you shine light on it, more current goes through. And so it's a little photo transistor. The base is open, and then there's a collector and emitter. So you connect the positive leg to ground, and the negative leg, the shorter leg, through like a 10K resistor to ground. So from like 3 to 15 volts to ground, and you use it basically. You wire it like an LED. But when you shine light on it, the amount of current that goes through that choke resistor will increase, and so the voltage will rise. And basically it's a way to measure light. There's a little bit of a filter on it. I think it's an IR filter, just to make the spectral response more like human eyesight. And the reason we have this is photocells are not RoHS compliant. So we wanted to have something that was very similar to a photocell. It's pretty much equivalent in function. It is polarized, but it doesn't have cadmium in it, and so it's RoHS compliant. So for some people's projects or products, they need that, and this is an alternative.
Okay. I get it. It's on LED already. I get
It's
it.
not an LED. No, it looks like an. Well,
Okay.
it kind of is, but it's a backwards LED.
Okay, so this is exciting because we get a graphic and we have a product. This is Parts Pal. Parts Pal.
Parts Pal.
It's your pal that won't let you down. It's a bunch of parts. That's the theme song I'm working on.
Yeah,
Yeah.
it's a pal that won't let you down. Okay, the Parts Pal is this is actually a kit that people have been demanding I do for quite a while, and I finally got around to doing it. It's a it's a kit of kind of all of the parts that you would want. It's kind of a collection, an hors d'oeuvre or a little appetizer plate or poo-poo hot pot, whatever it is that you want to call it. It's a little bit of everything all together in a nice little case. And so let's maybe we'll go to the overhead and I'll go through it. So this is, move this over here. So this is the box. It comes with this box. It's a nice latching box. And inside there's multiple bags, and each bag contains a different set of components. So let's start with the big bag first. So you get, oh, hold on, this is not locked. Okay, come on. Okay, this is, oh, sorry, I hit the wrong thing. This is a half-size breadboard, so really handy. You can put components inside of it. You also get a stick of 40-pin breakaway header, so you can break this apart. You also have non-breakaway female header. Female header doesn't come in breakaway style, but you can cut it with snips or with strong scissors if you'd like. How did that get dimmer? You also have some wires. These are pull-apart wires, so you can pull them off, and you get 20 short wires and 10 long ones, and they come in 10 different colors, so you get like a full set of colors, so it's kind of nice. So good for wiring stuff up. These are really nice premium jumper wires, kind of my favorite jumpers.
I like some of the comments. Parts Pal looks shiny. Parts Pal is every maker's friend. Parts Pal will always return the money it lent to you. It never lets you down. Parts Pal.
It's true, Parts Pal.
Man, maybe we need to do a Parts Pal song contest.
Okay.
We're in the middle of a contest right now, but maybe later.
Okay, we'll do a song contest.
Okay. Everyone remind us later to do a Parts Pal song contest.
Yeah, like a theme song. Okay, you also get a bunch of LEDs. You get 5 green 5mm LEDs, and you get 5 red LEDs. That's kind of what we started with. And then you also get 1 10mm RGB LED. I just love these. These are just so handy because they're like really big. They're great for indicators. They're fairly bright as well. And you can use them in the breadboard, and you get RGB inside of them. So that's kind of nice for color mixing. Next up, we have some resistors. You don't get a lot of resistors, but you get enough to get started with. Here's 10 4.7K, 10 1K, 10 560 ohm, and 10 10K. So kind of like a little bit of a starter taster pack of resistors. These are kind of the resistors that I use the most, so I thought that would be handy. Come in a little bag. You also get a bunch of capacitors. These are really handy because you can get resistor kits, but capacitor kits are rarer. So this is 10 microfarad 50 volt. So that's one set, and you get 5 of those. You get 5 100 microfarad 16 volts. So of course, the lower the capacitance, the higher the voltage. It's usually a trade-off. We want to keep it. So if you really need high voltage, use 10 microfarad. If you are using everyday voltages that most makers use, the 100 microfarad will work fine. And then we have 50 volt capacitors, and I'm not going to sort these out, but we have 10.1 microfarad, 10.01 microfarad, and 10 1.0 microfarad. So you kind of get a range of capacitors, and the little numbers on them indicate which the value is. So that's kind of handy. Okay, so you get capacitors, resistors. Next up is mechanical. These are mechanical parts and some sensors. You get a piezo buzzer. I love these. You can make beepy sounds. You can also use it as a basic tap sensor. You can show a microcontroller pin. When you tap it, there's a little bit of a voltage spike. And also when you square wave out to it, you can make tones. So very handy, breadboard friendly. You get 3 breadboard friendly slide switches. They fit into a breadboard, and they have single pole, double throw. Yeah, that's right. I always get those confused. Slide switch, so it's kind of handy. You get 3 of those. You get 5 6mm tactile switches. These are also breadboard friendly, and press, and then the pin's short, handy for basic interfaces. These are super common. You get a 1 kilo ohm potentiometer. So these are nice breadboard friendly potentiometers, and with the twisty knob. And you get a 10K one, so you get one 1K and one 10K, so it's kind of nice. One of each, and nice knob with an arrow. Again, breadboard friendly. You can use it with that solderless breadboard. All this stuff is breadboard friendly, which is kind of the point. You get a 10K thermistor. It's not as nice as an analog out temperature sensor, but we have code example. You can use it as a temperature sensor. You just need one of the 10K resistors and set up a divider, and then it's quite easy to measure the voltage and convert it to temperature. You get a photocell, so a light sensor, and you get a vibration switch. So when you flick it or when something moves, the 2 pins short together. So it's another easy way to sense motion. I call it the poor woman's accelerometer. If you just want to tell it something's moved, this is a good sensor to use. Okay, so those are the little sensors and such. And then we're not done yet. We have one more baggie. You can tell there's a lot of parts. There's like 170 total parts. And this is the anti-stat bag, so you can tell it's going to be silicon components or semiconductor components. So you get 5 power diodes. These are 1N4001 power diodes. These are good as flyback or power or full wave or half wave rectifiers. So it's 1N4001s. You get 5 single signal diodes, 1N4148s. Can be used as small flybacks, but also really good for just signal diodes. You don't want to use them for power regulation so much. But if you want to have voltage go only one direction, you want to use this as part of a filter or something, you're useful. I'm always using diodes and stuff for things. This is, one LD33, 3.3 volt, 1 amp or so voltage regulator. So if you need a 3.3 volt output, you get that. 2 7805s, 1 amp 5 volt regulators. So handy if you need to get a 5 volt regulated output. And then you get 5 NPN transistors and 5 PNP transistors are kind of common. I think they're like 30 volt transistors, about 200 milliamps probably each. Good for all sorts of power switching. You can actually do quite a bit. These are pretty good transistors, so if you want to power high voltage stuff from a microcontroller pin, you can use this. You can use it for powering a small motor with the flyback diodes and do basic stepper motor control and stuff. You can make it a slightly crummy but still functional H-bridge if you really, really needed to. And then finally, TLC 555. So this is a wide voltage range and low current 555 timer. I really like this particular 555. It's a little more expensive than the NE 555, but it's CMOS, not TTL. So it comes in foam, and you can run off of batteries. You can run off of a AAA battery even, which is really nice. And I think it goes up to a megahertz. So great for all sorts of timing needs.
All right, that's Parts Pal.
There's a lot, but I want to explain every component. So I think it covers everything that you need. I'm not against adding more parts later, but I wanted to get started with this. I wanted to basically be able to make it $20 because I think that's an important price to hit, so that you can, when you get this, you know that you'll have enough to build all the projects that you're working on. I mean, it doesn't come with a microcontroller. You'll want an Arduino or a Raspberry Pi to go with it. But no matter what you have, you can probably make it work.
Yeah.
Like, there's a lot of components that will can be used with any kind of microcontroller or microcomputer electronics project. You can do analog 555 timer. You
Except no imitation. Don't buy Breadboard Buddy. He's not your buddy. He's not your buddy.
Breadboard Buddy's a liar. Actually, it's not a bad name. Actually.
Yeah.
Breadboard
Well,
Buddy,
no, because
Parts Pal.
when we think about names, there was this doll back in like the 80s. It was like my buddy, and me, and then the movie Chucky came out, and it was this doll that like hurt kids and stuff, and it was super scary. So that's why it's not Breadboard Buddy. It's Parts Pal.
We also wanted to have it be gender neutral.
Yeah. Yeah, pal is pal.
Mm-hmm.
Yeah. Okay. All right, and the star of the show, besides you this week, is
It's a precision real-time clock.
this clock thing.
We're going to be making a featherwing out of this as well. It's coming soon. But this is a little breakout for the DS 3231. It's a high-precision real-time clock. What's neat about this is it has the crystal that normally would come with your real-time clock, this little 32 kilohertz crystal. It's inside the chip. And there's a temperature sensor. And the temperature sensor measures how the temperature is moved up and down and uses that to compensate the crystal so that it can keep time very, 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 very precisely. I think it's like 2 parts per million precision. It's something ridiculous. It's pretty much the most precise real-time clock we've seen outside of a temperature compensated clock standard from like cell towers. People always pick those up on eBay. Those are totally awesome, but if you want something that can fit on your breadboard and off a coin cell, this is your best bet. It's very small and cute and breadboard friendly, so if you need precision real time, this will work. It has this battery backup capability. It's all good.
Yeah. All right.
More feathers next week.
That's right. Okay, and with that is new products. That was it. Bing.
Woot.
Okay, so we have a special treat this week. Everyone's favorite segment. It's not out yet, don't ask. In the Magic Vault. What will Lady Ada show us this week? Well,
Top secret feather stuff. We
got
got
feather.
feather Fona, finishing up testing right now. Super cute. And we also have Ada logger feather. So this will allow you to add data logging real-time clock. It's not that precision real-time clock. It's not as precision, but still a real-time clock. Add on top, and you can have a cellular data logger. And so this is 2 more feathers coming out shortly. Very exciting.
Okay.
32U4 processor. Battery backup. It's a little bit longer than the other feathers, but you get a cell phone module, man. It's got it. I even had the audio brought out.
Yeah. Okay. All right. Folks can start asking their questions in the chat. While you're doing that, I'm going to display the code. Pi hack Ada. If you like this type of programming on the internet and you want to see people like us keep doing it, please buy something. Use the code. You'll get 10% off tonight all the way up to 11:59 p.m. Eastern Standard Time tonight. If you want to do the trifecta, go up to $200. You get free UPS ground if you're in the continental US, and then you get also a free half-size Perma Proto, and you get 10% off. It's crazy. Lady Ada's crazy sale and House of Pancakes is what we're going to rename the company to. Okay.
Yeah.
So
Waffle House.
Yeah. So let's answer some questions.
Okay, let's do some questions.
Yeah, we're going to do a speed round.
Speed round.
Okay.
We had a lot of ranting.
Well, we just got chatty about it. Well, you know what? The next million orders is what we're really interested in, and the next million thank yous, and like now it's a time of reflection. Like, okay, that worked. Phew.
No, it was a roller coaster.
Okay, can I power the Pi 0 and TFT screen for the Pip-Boy 4 from a lipstick charger instead of making a circuit and using the LiPo charger?
You can. Yeah,
Okay.
it'll work. It should actually run a fairly long time, but it's just a little bulkier because you have to fit that in. But yeah, try it out. I mean, just watch out to make sure that when the battery goes low, you shut down your Pis. It's kind of good to shut down your Pi rather than having the battery die on it.
Okay, what do you think of the new Atmega 328 PB with more PWM and the 2 I squared C buses?
I think it's awesome. I kind of wish they made it a Atmega 64.8. That would have been really cool. But to get double the RAM and double the flash, that would have been a really nice upgrade since they did that with the Atmega 8 to the 168. Then they did the 328. That was really 328 is kind of when you can actually start doing stuff. Oh man, 64 and then having like a 4K RAM would really do wonders. But I'd love to check it out. I'm going to order some. I don't believe it's available in DIP though. I think it's only available in TQFP.
Okay. Is it possible to convert analog 3.5 millimeter audio to USB digital audio for USB headphones? Yeah.
Yes. Wait.
They want to take analog in and then convert it to USB headphones. There's devices that do that will get audio in from a source and USB. So it's possible. I think I have a device that does that.
I know you could do it with like a Raspberry Pi or computer because you'd have to have 2 audio interfaces. You'd have to have 2 USB ports. One would be an audio input USB, and then one would allow you to plug the USB headphone in. So, I mean, you can do it.
Yeah.
It's challenging.
The audiophiles won't like it.
Yeah, if you can get a headphone that has audio, I mean, yeah, you can do it, but you have to have a computer to do the analog processing in and then convert it to a USB signal out. Like you can't do it with a microcontroller, I don't think.
Sensor question. Any suggestions on good ways to mount an enclosure for any of the temperature, pressure, humidity breakouts for outdoor use?
Yeah, what you want to do is, I mean, there are enclosures I've seen that have filters basically in them, but you do want to have some way to have air to get to your sensor, but you don't want to have it exposed. So I think you have to put a filter. I mean, it's tough because with humidity, you want to measure humidity, but you don't want to get water into your enclosure. So I mean, I think what people do is they have like filters that let just a little bit of air in and just to the sensor. Sometimes like sensors also have body enclosures, and like that part is the humidity sensor, because temperature is not so important. Like temperature, it's like you can pass through the enclosure and you can detect it if it's ambient. And barometric pressure and humidity, you might want to have your outdoor enclosure has all your electronics that are very sensitive to water and humidity, and then have a gasketed like sensor that comes out and is on like a cable, and then that part actually has a hole in it so that you can get barometric pressure and humidity readings. Not easy though, because you have to be careful. You don't want too much humidity, or you will damage. Conformal coat the hell out of your project.
I'm going to answer the next one. If you were to buy a $9 chip or a Pi Zero, which one you buy? I'm going to say both because they're finally. It's so cheap to do these now. You have to buy
it's
both.
like $15.
There's
Why
no,
not?
yeah, there's no reason not to get both because
They have their
they're
pros
so,
and cons.
They're so different, but together they're under $20.
Yeah,
you should buy both, and then when you're tired of it, give it to a kid.
Yeah.
Or something. Okay. Can the GPS breakout still function inside of a metal enclosure?
It can, but only if you use the external antenna. If you have a metal enclosure, the built-in antenna won't be able to work. And remember, GPSs are they have to be very, very sensitive. They're receiving messages from space. It's actually from space. So what you want, or geosynchronous orbit. So what you want to do is you can put the GPS itself into the metal box, but have the antenna coming out.
Okay. I can answer this next one too.
Yeah.
Any thoughts on the Arduino.org and Arduino.cc mess? Yes, buy from Arduino.cc. That is the...
We sell Arduino.cc.
Yeah, and Adafruit manufactures the Arduino.cc boards. These are the people who actually own and run Arduino. Those are the real Arduinos from the real people. Go to Arduino.cc, read their story, meet their founders, all the people that have been putting in all the work over the last 10 years.
And we've been doing this for 10 years. Like I know who's been doing all the work on Arduino. It's pretty obvious to me.
And when you see .org boards being sold, ask the resellers to buy real boards from Arduino.cc. It would help the open source hardware movement, and it would help good people who are doing a lot for electronics and more. So those are my thoughts. Next up. How can I attach two LDRs with my Arduino and then program to know if someone gets in my room or not, and to save energy to open lights with relay? So I think they want a sensor to know if someone's in the room, and if they're in the room, it'll turn on the lights. The best
sensor to use is actually not an LDR, but a PIR sensor. A PIR sensor detects human movement, and so if you use that, you don't have to try to measure light changes, you just measure motion. And then you would use your Arduino to count when the sensor went off, and then it could turn on and off a relay or a power switch tail to change your lights or your fan or air conditioner.
Okay, the last one. What sort size of mounting hardware do you recommend to secure an Adafruit PCB to an enclosure, like a feather, nylon? Since we have mounting holes, what do you suggest?
M2 nylon screws are the best.
Okay.
I mean, you can use metal, but you have to be careful.
Okay.
You might as well use nylon. It's not that much more expensive. McMaster-Carr carries all of this stuff.
Okay. All right. Let's.
Any more questions?
No, the same thing.
Okay.
Okay. That's it. That's it for tonight. Can always post in the forums. We're here every week. Thank you. Let's give something away.
Yeah.
What are the rules on Trivia Lady?
The rules are, if you've won something before, you can't win again. Only one winner per my lifetime. So if you have won something, please sit on your hands or go make yourself some hot chocolate or something. And don't give hints or whatever. If you want to be fair, you want everybody to have a chance to enter and win. Okay. The fabulous prize is going to be a Parts Pal.
You said your lifetime. When you upload yourself to what's going to be called a computer, does that count?
We'll figure that out when we get to it.
All right. So the prize is a Parts Pal.
Parts Pal.
Okay.
Your happy pal that doesn't let you down.
Okay.
Doesn't ask you to move.
Oh man, don't start breadboard buddy conversations.
Parts Pal.
Yeah. All right. So here's the trivia question.
Yeah.
In 1913, there's a famous terminal that opened up in New York. What's the name of the terminal? It was in our time
1913?
travel. 1913. Yeah.
What happened in New York?
Yeah. Let's see. It is not 42, which everyone guesses it's.
Yeah.
1913. Very special.
Which terminal?
Which terminal? Nope. Not Penn Station, sorry. And the winner is Green Apple Cam. Congratulations, Green Apple Cam, in twitch.tv/Adafruit. You win a Parts Pal. Please email support@adafruit.com and you will get it. Grand Central
Parts Pal.
Terminal.
You're a happy pal. It's fun to be with.
Parts Pal. We'll pick you up after school. Won't promise and not pick you up and. Oh, sorry.
Parts Pal doesn't go out for cigarettes and never returns.
Yeah, see how dark this could get really fast? Yeah. Okay. Anyways, Green Apple Cam, congratulations. What is the product ID on this? Do you remember? Or maybe I do. Oh no, $29.75.
$29.75. So Green Apple Can, when you email support@adafruit.com, say I won a $29.75.
Yeah.
Parts Pal. Parts Pal doesn't say you're not like other girls.
Oh man, I have to stop. I'm gonna turn this camera off.
All right.
All right. Okay. Well, thank you everyone. That's Ask an Engineer for this week, and
We have this zipper thing covered.
yeah, we'll be doing this every week for as long as we possibly can. And what makes it happen is your orders. So Pi Hack Day is 10% off in the Adafruit store, all the way up to 11:59 p.m. Eastern Time. This is what keeps this place afloat. Your orders, thank you so much. And we still haven't went to a bank or got a suit for a loan or anything. And
I don't even have
we
a
don't take
suit.
ads, and we like being
No
independent.
affiliate sales.
Well, one thing that I'm going to say this. I don't know how it's going to go, but we are independent not only as a company, but as a blog. And so we cover the things that we want to cover. We can interview anyone. We don't have advertisers. We're not tied to anyone. And so because of that, we've been able...
Is it actually about ethics in electronics journalism?
Maybe, but the thing is, when we see things out there now, we email people and we're like, hey, do you want to do an interview on our site?
I had some great questions for the
Yeah.
FTDI
So-
CEO.
so-
I mean, actually, I have some questions.
Yeah, so we're actually going to finish right. We emailed FTDI and we said, hey, like there's a bunch of stuff going on about FTDI chips. And they wrote back, and so we're going to see what happens. We were able to get a sort of interview with the new MakerBot CEO. You were able to interview the CEO of Micro Center.
Yeah.
You were able to interview Paul Horowitz
That's cool.
from Art of Electronics.
I kind of fangirled a little bit.
Yeah, but I'm just saying, it's like they're out of all the places online for people in this industry, Adafruit seems to be one of the places. So thank you for making an independent place online for everyone. You know, sometimes there might be like controversy and whatever. Like it'd be great to have both sides or multiple sides to a story, and then people can look at it. It's not driven by advertising or sponsors or whatever. So
Yeah.
I like that.
Yeah.
So the reason we're able to do that is because y'all are buying breakout boards.
All right.
from
Well,
us.
you're a well-connected journalist.
Yeah, right. Not.
I know. That's why it's funny.
I know. No, it's one
You
of
went to
those.
journalism school. You can go to journalism.
No, it's funny. It's like it's one of those things where I keep thinking one day there's going to be media outlets that are covering this maker movement in a significant way. There's really amazing stories, and there's not. It just hasn't happened. The stories aren't being told, and people aren't doing interviews with the people that are rising to the top. And then later, like what happens when a company or something doesn't work out. I'll say this: the Kickstarter folks are really smart. They hired a journalist to go and investigate why a Kickstarter didn't work. It's so smart.
That's smart.
That was so smart. One of the coolest things.
I mean, the answer was kind of what everyone knew, but yeah, whatever. I mean, at least they
Yeah.
went through and they looked at why. Turns out hardware's hard.
Hardware's hard. Okay.
Okay.
All right.
We're
we'll see
gonna go
everybody.
have dinner.
Yeah. Well, we got to type up those questions.
You type those questions.
All right. We'll see everybody next week.
Later.
Here's a picture for Kat. Here's your moment of Zener.
You can see the cat on the desk.